All right, so let's get down to it. So again, suppose instead of having the theoretical results where I just list every sample out, obviously it's going to work out if I just do it theoretically. Let's deal with realish data, where I do a whole bunch of random data. Let's see if it lines up the way it's supposed to. So I have prepared 100 random samples. I'll sell this spreadsheet. I'll share the spreadsheet with you guys up ahead. But anyway, I've got 5 fellas, and essentially they all have either 3 or 8 or 11 rabbits. And then I've got 100 such samples of 5 people, so that's 500 people total. And I want to know if the mean of my means and the mean of my variances all come out to be the population mean. So let's see here. So I do it for every single sample. I find the mean of each sample, etc. And then I do the mean of those statistics. And all of those things are about to be graphed, and we'll see how it looks. First things first, let's look at the sample means. I have, again, 100 means here, and they do form a nice bell curve. How about that? They form a bell curve, and actually our sample mean, if I take the mean of those means, I get 7.3. The parameter mu is 7.3, like we found. So that tells us a couple things. Tells us we have a nice normal distribution of sample means. And also, if we take the mean of those means, we will approach the actual parameter. That's great. In fact, there's a word for it in your textbook. It's called an unbiased estimator. There is nothing wrong with taking sample means. And then the mean of those means will give you, or at least approximate, right? The more samples, the bigger the samples, the closer the approximation is supposed to become. But it's a great estimator of population parameter, specifically the parameter of mean. In this case, mean bunny rabbits. Next up, we've got the median. Median is not so good. Median does not do some great stuff. For us, there were 3 different medians we could have for our samples. We could have a median of 3. We could have a median of whatever in here. We could have a median of whatever in here. And that was all we really came up with. And that was because I had 5 numbers exactly. So the middlest number was either 3 or 5, or I'm sorry, 3 or 8 or 11. That's all I could have. And because of that, we do have some problems with median. Median is not great. It's a biased estimator. I do not recommend taking the mean of medians. Same for range. Range is another biased estimator. And that is because if you take a sample of your full data set, you will never have, well, you might have, but you will never have a bigger range. You'll almost always have a smaller range. And so the range can only go down, meaning this cannot form a normal distribution. Range does not make a good estimator. So don't do sample ranges. That's a typo there. I'll get that corrected. Variance, however, pretty good. For my 100 random samples, the theoretical parameter should have been 10.89. I got about 10.51, which is pretty close, honestly, especially considering how it's calculated. One thing to say is, yes, this is an unbiased estimator. Another thing to say is it's not a perfect normal distribution. It's called skewed. It's a skewed estimator. Still unbiased. It will still work. You can still take the mean of sample variances and get a good estimate of your overall variance for your overall population. But the actual graph is not a perfect normal distribution. It's skewed. Same, if not even more obviously so, for the sample standard deviations. Another typo there. This is standard deviations now. I take my curve here. You'll notice it does form a normal curve, but you'll notice on one side it's a slower rise, and on the other side it's a faster rise. That is skewness in a nutshell. But just like before, it is unbiased. Technically, your textbook insists it is biased, but it's close enough, whatever that means. But I like it. I like it. It's a good one to go with, right? Our sample was 3.1. The theoretical parameter was 3.3. Pretty good. So finally, I'll leave it here, and I'll see you in the next video.